All right, we're gonna go over, which ones we're going over, 1 and 2? So we go over 1 and 2, we're done.
Yeah.
I took a look at the test. You guys better be integral ready.
Let me review integrals since we'll have so much extra time on.
We did the integral review already.
We just have an integral review every time we have a test.
So just make sure to maximize your score, write an integral for each problem. Like I told you, a lot of the problems, you only have to write the integral. But even the other ones where you gotta like find the volume, surface area, or centroid, write the integral. Okay, number 1 came out to a good integral. That's the kind I like. 0, 0, 1, 0, and 1, 1. Find the surface area of the part of the parabolic cylinder. Z equals y squared that lies over the triangle with vertices. So this is the part that's over the xy plane, this region right here. Okay. So what's the formula for surface area?
Square root of
Double integral over omega, this is omega right here, of the square root of the partial of z, well, what's the partial of z with respect to x? That's about 0. What's the partial of z with respect to y? 2y. So it's going to be 0 squared plus 2y squared plus 1 dy dx. So here's omega. Let's integrate with respect to y first. So y is going to go from the y down here to the y down there. So this is y equals 0. This is y equal x. So it's going to be from 0 to x. And then dx is the last one, got to be constant, 0 to 1. Did we at least get the correct integral? I don't know. Parker here has a blank paper.
Sorry, I was really tired last night, so sorry.
Only had 2 problems for homework.
Yeah, no, but I have practiced like 16.
Oh, boo, boo, boo.
I'm not crying, I'm just saying. Cause you asked.
No, I'm crying.
Okay.
So this simplifies to 4y squared plus 1. Now, if you, from experience, you know that this is going to come out to a secant cubed integral, yeah?
Wait, you didn't draw
Oh,
the z equals
Oh, it's up here. It's like the surface is up here somewhere.
Oh, what is 0?
This is omega. This is like, oh, so this is a graph. Like it's a surface, yeah?
Yeah.
So you have to find the surface area of that above this. So like the surface is up here. So find the part of the surface that lies directly above this.
Okay.
So it's over here like this. Okay, so this integral will do the job. Well, look at this. Okay, when you see an integral, this is what you gotta be thinking. Is it on the list? No. Can I do a U substitution? No. Can I do integration by parts?
No.
No. Can I do partial fractions? No. Can I do a trig substitution? Yes. And the last resort is Z substitution, but there's no Z substitution ones on the test. But you gotta be good at these other ones. So what is the trig substitution here?
Tan.
Yeah, okay, the tangent one, so what?
No.
So what? 2y equals tangent theta. So that you get tangent squared plus 1, because you want the identity. That's what you want. So therefore, 2 dy equals secant squared theta d theta. Correct? So we're doing this integral first, yeah? We're doing that one first. Okay, so if I make the substitution there, you get the integral, we're gonna need a lot of room here. The integral of the square root of if tangent squared theta plus 1. And what do I substitute for the dy? What is dy equal to?
Secant squared theta over 2.
Secant squared theta d theta over 2. I'm going to put the 1/2 on the outside. And what are my new limits of integration? If I plug in 0 for y here, tangent of what angle is 0? 0, that's easy. And then if I plug in x, if I plug in x there, What is
Tan
theta?
inverse of.
Tan inverse 2x. Okay, here we go. But isn't this secant squared theta? That's why we did the trig substitution. And what is the square root of secant squared theta? And don't say secant theta.
Absolute value.
Absolute value of secant theta. However, on this interval it's positive. Ow!
Okay.
Sprained my finger. 1/2. So basically it is secant theta, so we end up with a secant cubed. Now remember I told you when we did the review, if you're gonna enter integral competitions, this is one you might wanna memorize. Anybody?
Oh, 1/2.
Wait.
Oh, oh,
1/2 secant theta tangent theta plus
Oh.
secant squared.
oh.
You had the first part.
You had the
Get
first part. Okay, so obviously we don't have it memorized, so we need to compute it. We gotta go off on the side. I'm gonna leave that integral there. So, let's do a refresher. How do we integrate secant cubed x dx if we don't have it memorized? We gotta split it up into secant times secant squared, and then do, this is what you wanted, Wayne, the
Yeah.
integral review.
I'm writing it down.
No, you have to.
Integration by parts.
Okay.
So u du dbv. Now which one should I put as u?
The secant.
Secant or secant squared?
Oh, secant.
Secant. Why do you want this one to be the secant squared?
Couldn't be. Would become.
Because then you get, yeah, then it's tangent. And then this one is secant x tangent x dx. So, the integral of u dv, which is the thing you're trying to find, I'm just going to put secant cubed x, is equal to u times v, secant x tangent x, minus the integral of v times du. So that's tangent squared x secant x dx. Okay, now here's the key step. What do I do with this tangent squared right there? You replace it with
Secant squared x.
secant squared
X minus 1.
minus 1. So let's see what we got now. We got the integral of secant cubed x dx is equal to secant x tangent x minus the integral of secant cubed x plus the integral of secant x dx. I forgot to write the dx here. Right, if you distribute this minus sign and split it up into two integrals. Yeah, but Mr. Park, this is the integral we're trying to find. Yeah, that's good. So move it on this side. 2 integral of secant cubed x dx. Remember what this technique is called?
Oh, solving for the
Yeah, solving for the unknown integral. Plus the integral of secant x, which is on our list. Wayne?
What?
No, you're not Wayne.
That's it for me, Jason.
Jason W.
Uh,
From now on, you're going to be known as W.
oh.
And you're C.
Okay. Hopefully that's not a grade.
Could be worse than that.
Tangent.
What? This is on the list. Okay, I'll start you off. Natural log, absolute value.
Tangent.
Secant x plus tangent x.
He's gonna say
He's gonna say
tangent x
tangent
secant
plus
x. He's gonna say.
Yeah.
Oh, you were going to say tangent plus secant.
Yeah.
Exactly what
Oh, I should have let you go longer. Plus c. And so therefore, all you have to do to get rid of this 2 is multiply by 1/2, so over 2, and a constant divided by 2 is a constant, boom. See, so P, remember the first part, but you forgot the,
Oh.
so.
It's so confused.
So the integral of secant cubed is secant theta tangent theta over 2 plus natural log absolute value of secant theta plus tangent theta all over 2 from 0 to tan inverse 2x. In fact, why don't we factor out that over 2 business, yeah? Shall we do that? So factor out the over 2 and then this would be over 4 then. Now, it looks like we're going to have to draw a triangle. How do you draw an angle that's tan inverse 2x? You go opposite over adjacent, And then Pythagorize 4x squared plus 1. So looking at the picture, you get, look at the picture, what is secant theta? This is theta right here. What is secant theta? Well, if cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. Root 4x squared plus 1, and then tangent is 2x over 1, plus natural log, absolute value of secant, which is root 4x squared plus 1, plus tangent, which is 2x, minus, if you plug in 0, you get 0 plus 0. Natural log 1 is 0. There you go. That's what you get. Now we got to integrate with respect to x from 0 to 1. So now we got to go integral from 0 to 1 of this thing dx. So let's split this up into two integrals. 1/4 times the integral from 0 to 1 of 2x root 4x squared plus 1 plus, dx, plus the integral from 0 to 1 of natural log absolute value of 4. Actually, we don't need the absolute value because x is going from 0 to something, so it's going to be positive. Root 4x squared plus 1 plus 2x dx. Now this one is easy, that one is not that easy, but we did it in BC last year. Yeah, I gave you guys a worksheet. Integration by parts practice. Ooh, I just gave it away.
Wait, what?
Integration by parts. Okay, let's do the first one. The first one is easy. What technique are you going to use here? C.
U substitution.
U substitution. So this first one, U substitution. U equals what? H?
4x squared plus 1.
4x squared plus 1. Du equal 8x dx. So this integral becomes the integral of, shall we put the 2 on the outside? Put the 2 on the outside? So you got root u, and what do I substitute for the x dx? 1/8 du, and what are my new limits of integration going to be? If I plug in 0, you get 1, you plug in 1, you get 5. Hey, that's where the root 5 is coming from. So we have 1/4. The antiderivative of root u is u to the 3/2 with a 2/3 in the front, but I'm going to factor that out from 1 to 5. And so you get 1/6, 5 root 5 minus 1. Okay, let's store that. That is this. Okay, are you guys following? Okay, I'm going to have to erase this. We don't need this already because this is the last part of the integral. So, now how do I compute this integral? Well, I already gave it away. Integration by parts. U du dv. So obviously this one has to be the dx and this one has to be the natural log of gorilla. Okay, fill in the chart. I'll do this one. X. And who's got this one because it's going to need some space here. W.
1 over root 4x squared plus 1 plus 2x times 2 plus I don't know.
Come on, box to the 1/2.
1/2 4x squared plus 1 to the negative 1/2.
I hear whispering. I hear whispers. Times. Come on, chain rule.
Times 8.
X.
X.
What's going on? And then dx. Chain rule. That's, oh my goodness. Now that looks like a mess, Mr. Park, but you know what? If you remember anything from BC, that thing simplifies really nicely. So let's simplify the du. So you get 1 over root 4x squared plus 1 plus 2x. Now, this thing over here, that's like, okay, let's try to simplify that. 1 plus 4x over root 4x squared plus 1, correct? Because the 1/2 times 8 is 4.
Yeah.
Okay, now let's make a, I'm gonna go over, where can I go? Equal. Just go over here already. Equal 1 over root 4x squared plus 1 plus 2x times, okay, let's make a least common, look how beautiful this is gonna be. This is gonna bring tears to your eyes. If I make a least common denominator, what goes on the top? 2 root 4x squared plus 1 plus 4x. You guys see it?
Yes.
What? Oh wait, I used an equal sign. I didn't put the dx minus 1. You guys see it? You can factor out a 2 from this. If I factor out a 2,
Wait, what happened to
Oh,
x?
yep.
what do you mean?
I remember it was like,
No, everything is correct. See, look, now, that thing and that ugly thing, they cancel out.
oh,
Look, cancel, cancel. All you have left is 2 dx over root 4x squared plus 1. Well, you said there's an x?
yeah, where'd it go?
Oh, but this is just this part, yeah. That's just the du. We didn't put it together yet.
Oh.
Don't worry, there's gonna be an x. Okay, see that? So now, let's put it together. So this integral that I'm trying to find is equal to uv. Where's uv? uv. So, you're gonna use integration by parts. You guys probably forgot when you're doing that. uv, natural log, root 4x squared plus 1 plus 2x minus the integral of v du. What is v du? What happened? Look, here's v. v times du, so that's the 2x dx over root 4x squared plus 1. See, in that you can do U substitution. Shall we just finish the problem because Cho said the answer is wrong?
Yes, please.
Okay, so how do I do this integral? U substitution. U equals, in fact, is that the same thing we did before? No, it's a little different. U equals 4x squared plus 1. Du equals 8x dx. So come on, I gotta do all the work. So this integral becomes root u on the bottom, 2, and x dx equals du over 8, which means that's gonna be 1/4. Is that correct? Yes, and so that's 1/4, and that's like u to the negative half, so that's a u to the 1/2 with the 2 in the front. So that's just 1/2 root u. So putting it all together, you got x, natural log of this ugly thing, minus this integral, which is 1/2 root u, but if you resubstitute what u is, you get 4x squared plus 1. Woo! There you go. And then we got to integrate that from 0 to 1. Okay, plug in the top number. Natural log root 5 plus 2 minus root 5 over 2 minus, if you plug in 0, you get 0 minus 1/2. Are you guys better at least be checking to see if I'm making a mistake. Okay, so this thing here is this right here.
Oh, okay, so that.
Oh my.
Okay, now we put it all together. So 1/4 times this, which is this, so 5 root 5 minus 1 over 6, plus the other one, but the other one is this. And the natural log of root 5 plus 2 minus root 5 over 2 plus 1/2. Okay, is there any way we can simplify this?
Gotta want 6.
Last two.
I guess just make a least common denominator of 6, yeah? Nah, why are you even bothering with that nonsense?
Can you just leave it like that?
No!
Why not?
Because you can add this one and this one at least, right?
Okay.
Doesn't the last one.
Alright.
Okay, let's just add these three here. So you get natural log of 2 plus root 5. Okay, and then if you add this one in with these two, what do you get?
2, 5.
Shall we make a least common denominator of 6 for that then?
Yeah.
So
2,
5 root 5 minus 1
minus 2.
minus 3 root 5 plus 3. So what does that come out to? 2 root 5 plus 2. Factor out a 2, cancel it with the 6, and so you get 1/4 natural log 2 plus root 5 plus root 5 plus 1 over 3. Okay, what's the answer on the bottom? I'm gonna have to scroll.
Okay, Jason, I see what you mean now about this one taking 4 pages. Yeah.
Hey, there, the answer at the bottom, if they make a least common denominator of 12, oh, the answer, that's not correct.
I get an extra credit.
Why? For not paying attention in class.
Oh, boy. What do you, oh, never.
Okay, that's what I thought.
Wait, missed a part.
Okay, you know what, that's a good enough answer. So the answer on the bottom is slightly off. Anyway, that's the answer they told me when remember I told you? At the time we had, not Kaishu then, but before then. You know, Chang's brother.
Yeah, but then they Kachun guys do the same problem.
Yeah.
Yeah, what
But
happened?
they incorrected.
I don't know.
They never asked you to do it on the board, that's why they're wrong.
Wait,
No, I'm pretty sure we did it on the board.
Is that what you didn't correct?
isn't the answer we found for number 3 the same as the crossed out one for number 1?
But there's no pi though.
No, it's wrong.
We had a
No.
pi in ours
Yeah.
yesterday.
Yeah.
Oh, I lost it somewhere.
Shoot.
So you integrate from 0 to 2 pi, that's probably wrong.
Oh, well, you know what, I'm too old to go and change it. We just make a note of it, which I'm gonna forget like in 5 minutes, and then we'll just do it all over again next year.
No, no.
Wait, so you know like when you start out with the first integral and it's like square root of 4y squared plus 1?
The Trig substitution over here.
Wait, I know you can't do it, but why can't you do like power rule?
Oh, interesting. So you're saying the integral of 4y squared plus 1 dy. So it's simply make the power 1 bigger, put the reciprocal in the front, and plus c.
Does
Yeah.
that count?
Not even AB students
You
do
gotta
that.
account for the.
What about the derivative of the box, which is 8y?
Oh yeah, and then I multiply the.
Oh, so then you go over 8y then.
I did like something like that.
You cannot do that because if you take the derivative of this, you would have to use the quotient rule. And there's no way you're gonna get something that nice out of it. See, you're thinking that, okay, if the derivative.
Wait,
You want extra credit for that, for disrupting class? If the derivative of the box is a constant, then you can adjust for it. But if it's not a constant, you cannot do this because you would have to use quotient rule.
Wait, so like,
He's still pretty.
so like if it's a constant.
I'm sorry.
Wait, at least offer everybody if you're gonna do that.
Oh yeah, does anyone want?
Yeah, I want, just leave the bag open over here.
Okay.
Okay, so what's the question? So this is a no.
Okay, wait, so then like what's a yes?
Okay, a yes would be if the derivative of the box is a constant, like if you had 4y, the derivative of the box is 4, so then this one you could go, okay, I make the power 1
Oh, that
bigger,
makes sense.
put the reciprocal in the front, and the derivative of the box is 4, so then you adjust it with that, now that you can do.
Okay.
But if the derivative of the box is not a constant, then okay, then you gotta find some other way. That was worse than crinkling.
He was crinkling forever. That's so long.
You do that when you go to the movies too.
I don't go to the movie.
Thank goodness. Okay, one more problem and we're done. Number 2. So Joel, you did anybody do 2? H?
Yeah, it came up.
Yeah, I know.
Oh, yeah.
Moses even asked P.
Then I
W?
did the second limit though, I think.
Okay, that's
Yeah,
it.
yeah,
Find the surface of the a part of the hyperbolic parabola. Oh, I love hyperbolic parabolas. That was the name of our group.
Oh, yeah.
Thought it was.
We had a musical group, we were called the hyperbolic parabolas.
thought it
Isn't
was
that for
confused.
faculty quality?
Yeah, faculty quality is like 20 years ago. No, 25 years ago.
Wait, what, there's 2?
Mr. Strawn, were you here when Mr. Strawn was here?
No.
He was our lead singer.
Wait, how long
Who's
who's Mr. Strawn? How
He
long-
was a Latin teacher.
But how long ago was
I think he retired like, what, 3-4 years ago?
Oh, okay.
He might have been here. Okay, which lies inside of the cylinder, x squared plus y squared equals, come on! So since it lies above this cylinder, so if you smash it down onto the xy plane, that's what it's gonna be, right? X squared plus y squared equals 3. This is omega.
he?
Okay, so first we gotta compute the partial with respect to x, which is W.
Why?
Correct, x. X squared plus y squared plus 1 dx dy. Okay, but now, what are you thinking as soon as you see that? Since you
R squared.
see x squared plus y squared.
3.
I'm gonna do polar.
Okay,
So instead of dx dy, we're gonna do r dr d theta, right? And of course, what is x squared plus y squared equal to? R squared. And look, there's U substitution right there already. So since this is omega, r goes from what?
0
Zero
to
to-
0 to
3.
ah,
Oh.
√3. The radius of the circle is √3. And theta is going to go ring 0 to 2 pi.
It's only the something cosine theta where it's simplified.
Say that again?
It's only like, what? It's only like r equals.
Yeah, because this one you have to go all the way around. Because look, zing. It's just like when the circle is like over there, then 0 to pi goes all the way around. Yeah. Okay, now do you want me to do this integral? That's U substitution. Okay, you guys can handle that. All right, that one was an easy one. Now, yeah, some of them on the test will be easy like this, but then some of them not so easy. But if you're practiced, then it will be easy, right?
Yeah.
But then that's the problem right there, yeah. Oh, these are good. Delicious. They're right. Lay's potato chips, you can't just eat one.
That's their
That's in the, yeah, that's in the commercial.
Oh, I thought you said they're right.
Yeah, you're right.
Okay, they're right, they're correct. You just can't eat one. Mm. Mm. Okay, any last questions you want to bring up? Because Monday is the test. 4 pages of pure pleasure. Okay, I'm turning off the camera.